Okay, welcome to Miss Sussman's class. Please make sure you have pencil and paper to take notes. Our essential question is, how can you solve a problem by making a list? And I have to tell you, the essential question really should be, how can you solve a problem by making a list of greatest common factors? Because really that's what you need to know to solve these word problems. And we're going to work a couple, and then you'll have one word problem for homework. And then we'll be doing word problems all day tomorrow. So there's no actual computation for this particular lesson. It's a problem solving lesson. So let's take a look at the first problem. It says Susan sorts a collection of beads. There are 35 blue, 49 red, and 21 pink beads. She arranges all the beads so that each row has an equal number of beads and has only one color. What is the greatest number of beads that she can put in each row? Okay. These kind of problems sound crazy when you read them, and they are a little bit. But you're going to notice a pattern, and if it fits the pattern, it's going to be a problem where you have to use greatest common factor to solve it, and I'll show you. So we need to figure out the greatest common factor for 35, 49, and 21. And looking at those numbers, I see they're all multiples of 7, so I think it's going to be 7. But I'm still going to do it just to make sure that I'm right. So here we go. 135. It's not divisible by 2. It's not divisible by 3 or 6. It's not divisible by 4. And it is divisible by 5. And it's 5 times 7. So make sure that you put all of the factors of 35. And that's it. And then for 49, it's 1 and 49. It's not divisible by 2. It is divisible. No, it's not divisible by 3 because 4 plus 9 is 13. It's not divisible by 4 or 5 or 10 or 6. It is divisible by 7, and I know that because I know my math facts. Because 7 times 7 is 49. I don't really need to write the 7 twice. And then 21, 1, 21, 3, and 7. And yes, I was right. 7 is the greatest common factor. Now, what does that mean as far as the word problem goes? The question asks you, what is the greatest number of beads that she can put in each row? Well, if you have 39 blue, 49 red, and 21 pink beads, can you have more than 7 in a row? Each row has to have an equal number of beads and only one color. So you're going to have 5 rows of blue, because 7 times 5 is 35. You're going to have 7 rows of red, and you're going to have 7 rows of pink. And each row will have 7 in it. I am aware that these problems are difficult, but keep watching me work them and watch them over and over, and you're going to see the pattern that with the question, and that's going to tell you when it's a GCF problem. Okay, let's try another one. Okay, Barbara is creating gift baskets for presents. She has 28 bananas, 35 apples, and 42 oranges. What is the greatest number of identical baskets she can make if she wants to have the same amount of fruit in each basket? And what that means is she wants the same amount of bananas, apples, and oranges. And in order to do that, I am going to find GCF, and I'm looking at these numbers, and I think it's going to be 7 again, because those are all factors of 7, but we'll see. You never know. 2 and 14, 4 and 7. It's not divisible by 3 or 6 or 9 or 5 or 10. Let's do 35, which we did previously. It's 1, 35, 5, and 7. And then 42, 1 and 42, 2 and 21, 3 and 14. Not 4, not 5. 6 times 7 is 42. And again, it's 7. So what that means is the question's asking, what is the greatest number of identical baskets she can make if she wants to have the same amount of fruit in each basket? So by finding the GCF, we know that she can have 7 bananas, 7 apples, and 7 oranges in each basket. Okay, so, or she can only have, she can only make 7 baskets if she wants to have the same amount of fruit. Yeah, 7 baskets. All right. All right, so she can only make 7 baskets, and 7's the GCF. And you should be noticing a pattern here. Greatest number of identical baskets, and they give you these different numbers. You'll notice a pattern with these GCF problems. And that's going to help you figure out when to use GCF. Right now that's all we're doing, so that's what you need to do. But if this were like an AFCAT test, where you have a whole bunch of different kinds of problems, you want to be aware of, like when I see a problem like this, I'm like, oh, it's a GCF problem. And that's kind of where you want to get to, where you're like, oh, okay, I see. It's a greatest common factor problem. And then you just do the GCF and figure out how that applies to your problem. You're going to have one more that is going to be your homework. If you are having any difficulties, pause, rewind, watch these a few times until it makes sense. Okay? Let's move on to your homework. Okay, here's your homework problem. A food bank has 50 cans of vegetables, 30 loaves of bread, and 100 bottles of water. If they organize the food into boxes with the same number of food items in each box, what is the greatest number of food items they can have in each box? Okay, so you're going to use GCF to figure this out, and we'll discuss it when you come in tomorrow. Have a good night.